Hey Algebra 1, today we're going to talk about how to solve a system of equation using substitution. So last week we did graphing, and graphing, as it turns out, is imprecise. So sometimes your line gets a little bit crooked, it gets a little off, and so you're trying to figure out if a point is located at 2, 0, or if it's 2.5, 0. And so if you solve it algebraically, we get something more precise. So we're going to first look for these couple of rules. Number one, you're going to solve one equation for one of the variables. So nobody cares if you solve it for x, or for y. Some of them are already done, like 1 and 2. So y is equal to 2x plus 1. This would be saying like 30 equals 15 times 2. These are exactly the same thing, just different representations. So you're going to, step number 1 is already done. You're going to substitute it into the other equation. So in place of y, in that top equation, I'm going to get rid of it, and I'm going to sub 2x plus 1 in y's spot, and I'm keeping everything else. So I have 3x plus 2x plus 1 equals negative 9. So the purpose of doing this is that I can't solve an equation that has two variables in it, but if I could get creative and figure out how to rewrite it so that they were all the same variable, then I can solve. So I'm going to combine like terms with these x's, so that adds up to 5x. And now I'm just solving the equation as normal. Subtract the 1 over to the other side. 5x equals negative 10. Divide. And x equals negative 2. So now we know what x is. Now we have to figure out what y is. And it says substitute the answer into an original equation and solve for the other variable. So you could sub it into the first one if you wanted to, or you could sub it into the second one. Well, y is what I want to solve for, so subbing it into the second one makes a whole lot more sense. So in place of that x, I'm going to sub negative 2 in. So y equals 2 times negative 2 plus 1. That's negative 4 plus 1. So that adds up to negative 3. The last step says write your solution as an ordered pair. Okay, so it always goes x comma y, so the solution is negative 2, negative 3. So we have to write all of our solutions as ordered pairs. Check and make sure it works in both equations. So I'm going to plug negative 2, negative 3 into both these equations and make sure it works. So in that top one, I'm going to go 3 times negative 2 plus negative 3 equals negative 9. 3 times negative 2 is negative 6. That becomes a negative 3. Negative 6 minus 3 equals negative 9. You got to check it in both of them. So now I'm going to plug it into the y equals 2x plus 1. So y is negative 3. 2 times negative 2 plus 1. That's negative 4 plus 1. That adds up to negative 3. And so my answer is a good one. So the great thing about this section is that you should be able to check all of your answers. This one is already solved for one of my variables. This time it's x. That's okay. Doesn't matter if you solve for x or if you solve for y. So I boxed them in to try to give you all a visual that x and negative 2y plus 4 are exactly the same thing. So in place of x in that second one, get rid of the x and you sub negative 2y plus 4 in. So I have 2 times negative 2y plus 4. Bring down the rest of the equation. So I just substituted 2 terms in place of 1. Anytime that happens, you need to make sure you put parentheses around what you substituted in, because I have to distribute. Now, 2 times negative 2y is negative 4y. 2 times 4 is 8. Plus 4y equals 8. I'm going to combine like terms. Negative 4y plus 4y, that adds up to 0, so they cancel each other out. So I have 8 equals 8. All right, that's weird. So I don't have any variables, but this is a true statement. The answer to this one is the IMS, infinitely many solutions. This happens when the answer has no variables and you have a true statement. So what's really going on here is that you have the same line. So when we graphed last week, we had, you graphed one line, and then you had the second line directly on top of it. And so infinitely many solutions is what happens when you have no variables and a true statement. Number 3. All right, so y equals this and y equals this. So y and 3x minus 11 mean the same thing. So in place of y in that second equation, I'm just going to sub 3x minus 11 in its spot. So sub 3x minus 11 in. Keep your 3x minus 13. So you always move your variables first. So I would subtract 3x from both sides. That cancels out. I get negative 11 on the left. That cancels out. And I get negative 13 on the right. So this is kind of similar, but the opposite of number 2. This is a false statement. This is what no solution looks like algebraically. So when your answer has no variables, but you get a false statement, your answer is no solution. If you were graphing it, it means that the lines were parallel. And so since parallel lines never cross, there is no solution there. Number 4 looks like we have to do a little bit of work. So you have to use substitution on this one, but it's not already solved for a variable, so you have to do it yourself. Up there it says, look for the one that has a coefficient of 1 or negative 1. So that negative y right there has a coefficient of negative 1. So that's the one I'm going to solve for my variable. 2x minus y equals negative 1. So if I need to solve for y first, I'm going to subtract 2x from both sides. Negative y equals negative 2x minus 1. I'm going to divide every single term by negative 1. So y equals 2x plus 1. So y and 2x plus 1 mean the same thing. This is the equation that you solve for, so you have to plug it into the other equation. So into the 5x plus 2y equals negative 16. So I'm going to get rid of this y, and I'm going to substitute 2x plus 1 in its spot. So I keep my 5x, 2. You're going to need parentheses because you're subbing 2 terms in place of 1. We're going to have to distribute. 5x plus 4x plus 2 equals negative 16. I'm going to combine like terms. I'm going to subtract my 2 to the other side. And I'm running out of room. I'm going to divide both sides by 9. And x equals negative 2. So you can plug it in any one of these original equations. This is also technically an original equation because you just rewrote the top one. So y equals 2, plug negative 2 in place of x. Negative 4 plus 1 equals negative 3. You have to write your solutions as an XY ordered pair. This is how all of your solutions have to show up. All right, so we should, you should go in and you should check it. So if you plug negative 2 in place of x and negative 3 in place of y, I would have 2 times negative 2 minus 3 equals negative 1. That minus turns plus. Negative 4 plus 3 equals negative 1. That's a true statement. Now plug it into the second one. 5 times negative 2 plus 2 times negative 3 equals negative 16. That's a negative 10. That's a negative 6. And that is a true statement. So subbing them in and checking your work should not take too long. Let's do a couple word problems. The sum of two numbers is this. Twice the smaller plus 1 equals the larger number. All right, so since we talk about smaller numbers and larger numbers, I am going to define them. So x is going to be my smaller number, and y is going to be my larger number. Generally, each sentence is going to give you an equation. The sum of two numbers, so sum means that you're going to add them together. Is a word in math that means equals. So add these two and it equals 10. X plus y equals 10. Twice the smaller, so twice means multiply. The smaller one is my x, so that's a 2x plus 1 equals the larger number. The larger number is y. So once you have your two equations written, you have to solve by substitution. That second equation, I already have substitution built into it. So y and 2x plus 1 mean the same thing. So in place of y into that first equation, that's where I'm going to sub 2x plus 1 in. So I keep my x, sub in 2x plus 1, keep my equals 10. Combine like terms. Subtract your 1 over to the other side. Divide. and x equals 3. And then plug it into the other equation to get your other variable. So I have 2 times 3 plus 1 equals y. 2 times 3 is 6, plus 1 equals 7. So my solution is 3, 7. I would probably check it to make sure it works. So into this first one, x plus y equals 10. That would be 3 plus 7 equals 10. True statement. 2 times 3 plus 1 equals 7. 6 and 1 is 7. Good. Next one. A music store sold a total of 125 car stereo systems and speakers in 1 week. The stereo system sold for $104.95 and the speakers sold for $18.95. The sales from these two items totaled $6,926.75. How many of each item were sold? Most of the time, the last sentence tells you exactly how to define your variables. How many of each were sold? So I'm going to have X be the number of car stereo systems I sold. And Y is the number of speakers I sold. The next thing that you do is you look for your totals. Totals are what help you write your equation. The sales from these two items totaled $6,926.75. All right, so that is going to be my money equation total. And I sold a total of 125. So this is going to be what I usually refer to as my things total. All right, so the things that I have are stereos and speakers, and I sold a total of 125. So that just means X plus Y equals 125. The next total that I have is for money. So this is where you have to take how much each of them are, and that's going to serve as your coefficient. So the stereos are 104.95, and that is my X, and then the speakers are my Y. So I have 104.95X plus 1895Y equals the 6926.75. So on your money total, this is how the coefficients come into play, and you have money plus money equals money. So now I just have my two equations, and I have to use substitution. Nobody cares if you solve for X or solve for Y. You get the same answer. I'm going to subtract Y, and X equals 125 minus Y. So in place of X, in my second equation, that's where I'm going to sub in 125 minus Y. 104.95 times 125 minus Y plus 1895Y equals 6926.75. You have to distribute to get rid of your parentheses next. It's 13,118.75 minus 104.95Y plus 1895Y equals 6926.75. I have these two like terms here, so you should combine like terms next. That adds up to negative 86. Move your constant over to the other side, so subtract the 13,118.75 over. That equals 6192, negative 6192. Divide both sides by negative 86. And y equals 72. If you'd gotten a negative number, that would be super bad because we don't sell negative amounts of anything. So I sold 72 speakers, and to figure out the car stereos, I take 125 minus 72, and I sold 53. So I have 53 stereos that I sold, and 72 speakers that I sold. Oh, this is a long one. A snack bar sells two sizes of snacks. A large snack is $5, a small snack is $3. In one day, the snack bar sold 60 snacks for a total of $220. How many small snacks, how many large snacks were sold? Okay, so X is going to be my number of large snacks that I sold, and Y is going to be the number of small snacks. If you have your labels reversed, it's fine. We're going to get the same answer either way. To help me organize myself, so the large snacks, I know I'm going to need that in a second. That's going to be $5, and the small snacks are going to be $3. Now I look for my totals. I sold 60 snacks for a total of $220. So my things total are the number of snacks I sold. I have large ones plus small ones for a total of 60 of them. The money is the other total that I have. This is where you take how much they cost, and that becomes their coefficient. So $5 times the large ones plus $3 times the small ones equals $220. Solve for X or solve for Y, doesn't matter, you pick. I'm going to solve for X. So X and 60 minus Y mean the same thing. So in place of X in my money equation, that's where I'm going to substitute. Get rid of X and plug 60 minus Y in its spot. Distribute, so that's 300 minus 5Y plus 3Y equals 220. I'm going to combine like terms, so that adds up to negative 2Y. I'm going to subtract my 300 over, and get negative 80. Divide both sides by negative 2. And so I sold 40 small snacks. To figure out the large, just plug it into the other equation. 60 minus 40. I sold 20 large. And that's how we do substitution.